All right, so welcome to this session. Maybe some of you were already at my Loom talk just a few minutes ago. Yes? I'm sorry, there will be some kind of overlap on the Loom part, but hopefully you'll find more content that you didn't hear about on the Amber part and the Loom part. So my goal today for you is to give you an overview of, I would say, the most important features currently being developed and already published recently and soon to be published in the next few versions in the three topics, Amber, Loom, and Valhalla. And the reason why I chose these three projects from the OpenJDK is that they are the projects that are going to have an impact on the way we actually write Java code. There are many other projects being developed. Some of them are about the garbage collector, the just-in-time compiler, the way the JVM is working, but that is not something we interact with as I would say, code writer, right? We write code, so we are interested in records. The way the garbage collector is working, maybe it's not so much what we do for a living. Great. So that being said, there are other projects, but these are the three main ones I'm going to focus on, and I'm going to tell you more about that. My name is Jose. I'm a Java developer advocate at the Java Platform Group. I joined Oracle a little less than 2 years ago. That's going to be 2 years in a few weeks, by the way, or in a few days even. And I used to work at the university in Paris. I did that for 25 years and teach Java technology at that time. Maybe you've heard about the dev.java website, or maybe you didn't. So now you are hearing about it. That's a website that was opened as part of the release of the JDK 17 almost 2 years ago. And it's a website with any question you have about Java, including what we're going to talk about now, should have an answer on this website. There is this Learn tab that you can see with plenty of documentation. There are more than 2,000 pages of documentation if you print everything, so please don't do that. As well as content for community, for contribution to the OpenJDK project, and this kind of thing. So you should definitely visit this website if you're interested in what's going on in the Java space. Along with my friends working for the developer advocate team, we are publishing quite some content on many platforms. So we have the Inside Java newscast series published every 2 weeks that brings you news about the Java space. The Jeb Cafe that I do, it's about once a month. The Java website, I already mentioned it. The Inside Java podcast, as well as the Inside Java website, which is some kind of curated list of everything that is published on the Java space by Oracle, and the SIP of Java by my friend Billy. So you have video content, audio content, written content, and if you don't like to watch video, if you don't like to listen to podcasts, and if you don't like to read articles, then I think there's not much we can do for you. So maybe all you like is going to conferences, which is fine because we are already there. I'm very glad to interact with you. As I said, we also have content on the community web pages. So if you are looking for a Java user group close to your home, then you can definitely go to our page on Java user groups. And if you are running or creating a Java user groups and need some information, advisors, anything, please connect with us and we'll gladly help you in doing that. Right. I myself run the Paris Java user group, and I've been doing that for 12 or 13 years. I can't really remember when I started doing that. All right. And this is quite a recent picture of me. Well, not that recent, actually, with links to the content I like to publish online. Great. So everything I'm going to talk to you about relates to projects that are being developed under the OpenJDK website. The OpenJDK is actually a place. It's an association of people, right? OpenJDK.org or OpenJDK.java.net, which are basically the same website, will take you to this place. Sometimes I hear people, oh yes, we are downloading the OpenJDK, thinking that they are downloading the JDK from the OpenJDK. You cannot actually download the OpenJDK. It's not possible because it's a house, all right? It's like a jug or an association of people, and you cannot download a house, right? It doesn't make sense to do that or to say that you're doing that. So you need to connect to this website if you want to learn more. And if you want especially to test what I'm going to show you as of today, sometimes you will need to download early access versions of the JDK, and this is the website, the page on which you can have access to that. You can see that there is already a JDK, actually, yes, an early access version of the JDK 21, which will be released in September, but there are already early access versions of the 21, and you can see that you have early access versions of Loom, Panama, Valhalla, and other projects that you can check out. So we are going to focus on these three projects. The project Amber is about adding a feature of a language feature, which is called pattern matching to the Java language. Okay, pattern matching has nothing to do with pattern matching for strings of character or regular expressions, for instance. It's really something that is completely different. It's an old idea from the old days of functional programming in the 70s. That is now coming to the Java platform. So we're going to talk more about that. Okay, the second one is the Loom project. Loom project is a new concurrent programming model for the JVM, the Java platform. Okay, there is one new concurrent programming models every 10 years on the JDK. So in 1995, there was this first model. 2004, that was Java Util Concurrent. 2014, that was CompletableFutures and the Forgeon framework. And now 2023, 24, that's the Loom project that is coming. And we're going to talk more about it in a minute. And Valhalla is about, sorry, this thing is not working. Okay, and Valhalla is about bringing a new type system to the Java language without breaking what is currently existing. And that's a massive challenge, I can tell you. So we're going to talk more about that. So first, Project Amber. So the first thing that you may have heard about is records. Anybody already played with records? Okay. Oh, almost everyone. So you already know records well, right? Are there people that do not know records at all? Okay, still a fair. Okay, so we are going to go through the details of record. Record is just that. Okay, that's a record. That's a declaration for a record called rectangle. A rectangle that has a width and it has a height, and that's how you define it. Okay, a record is just like a tuple, if this word makes sense to you. It's just that in that case, two integers gathered together in an object, and this object has a name, which is rectangle. Okay, everything has a name in Java, so even tuples have names, and that's why records have been designed like that. So it's a name tuple. It's built on components. This width and this height are the components of the records, and this components is a notion it's actually a new notion in the language. If you check the reflection API, the class named class, you can test if this class is actually a record, and if it is, then you can get the array of its components, and you have a component class to model the components of a record. So that's really a new notion in Java. It is modeled internally by a class. This class is final, okay, and it cannot extend anything. That is, if you try to extend another class with a record, it doesn't work. It will not compile. All right. So you are giving up mutability because a record is immutable. You are giving up inheritance. You are giving up also the fact that you can extend a record. You're giving up many things, but in exchange, the compiler will give you something. So you're giving up something, but you get something in exchange. So maybe it's a good idea to do that. All right. The compiler gives you a canonical constructor. That is the constructor that takes the component as parameters. You don't have to write it. The compiler will generate it for you. It also gives you one accessor for each component. So you have a width method and height method. It's not get width and get height. It's just width and height. And it also gives you a toString equals and hashcode method. So all this is already in this class. I do not need to write it. It's all there. It's not in the source code. You don't need it. But this is what you get. With a record, you cannot add any instance field. That's forbidden, even if it's final. If you try to private final int I, doesn't compile. Okay, so you cannot extend a record, and you cannot records cannot be extended. But on the other hand, you can write your own accessors and constructors in case you want to do some defensive copy, for instance, or validation. That's why you may want to write your own elements. And you can add any instance method or any static field or method. That's also legal, even private. Okay? And of course, you can provide your own version of toString equals hashcode. In the record, if you're not happy with the default implementation that is given to you by the compiler. So if you have a user record, for instance, you can write this user record in this way, where in the constructor, in a canonical constructor, the constructor that takes the component, you actually are doing some validation. You don't want a null name, and you are copying the value of the argument in the field yourself. You need to write this kind of code. Okay, so this is just validation. If it was a record with a list of cities, because a list can be mutable, and if someone keeps a reference from the outside of your record to this list, and you don't want this person to mess up with your internal state, so maybe doing a defensive copy is a good idea. So you can do that in a canonical constructor that you write yourself. All right. Now, there's another way of writing a canonical constructor, which is called the compact constructor. For instance, for the user object, where you're just doing some validation on the name. You don't want the name to be null. Then you can omit the declaration of the arguments or the parameters of this constructor. And this form of the constructor is called the compact form of the constructor. It's compiled in the same way, right? So there's no difference. It's just some syntax that is lighter. This syntax is good if you want to do some validation, for instance. All right, so that's a quick overview of records. Now, there are two golden rules with records, and one of them is, the first one is super important to have in mind, because that's really why records are actually part of pattern matching. If I'm talking to you about that, because records are a critical component of pattern matching, is that a record cannot carry any other state than its component. Okay? You don't have an instance field, you cannot extend anything, and you cannot be extended. It means that when you look at the declaration of a record, you have all the state this record can carry in front of you. All right? And that's very good, because there's nothing hidden with a record. Now, maybe some of you say, oh, it's breaking encapsulation. Well, yes, it does. So what? Too bad. So you give up also encapsulation with record, but you get nice things, and we're going to see more in a minute. Okay? A record, the second golden rule is that a record cannot be built without calling its canonical constructor, even with serialization. You know that serialization is a backdoor for so many things in the Java language. It's also very costly to evolve the language. But with records, because records are a new notion in the language, serialization has been designed in such a way that when you deserialize a record, the canonical constructor is called, which is not the case for a regular class. If you deserialize a regular class, no constructor is called. So if you have validation rules in your constructors, these rules are actually not called, which is a security breach. So that's for record. If you have any question, please ask them along with the presentation, because if you will forget about the question you have at the end of it. So I prefer to, if you have questions, just raise your hand, shout, make some noise so that I can see you and I can hear you. Along with records, for pattern matching to work, there is a second notion that has been brought by the Ember project, which is the notion of seal types. Okay, maybe some of you already heard about seal types. Yeah, most of you? Great. All right. So a seal type can be any type. In Java, you have classes, abstract classes, and interfaces. By the way, records can implement any interface. Cannot extend an abstract class, but it can implement can definitely implement an interface. And here is how you can define an interface called shape that is sealed. And along with the declaration that this type is actually sealed, you also need to add the elements that are permitted to implement to extend this type. So here the type is an interface, and only square, rectangle, and random shape can implement this interface. Now these types must be either in the same package as your interface or in the same module if your application is built on modules. So there is a limitation there. And the reason is that the compiler wants to see all your sealed hierarchy in one go. So there is no way for you to say, oh yes, this type is sealed. By the way, you cannot see that class, it's somewhere else, but it will exist in the future. The compiler doesn't accept that. It wants to see all the hierarchy in one pass. Okay? The extensions, so the classes, square, rectangle, circle, and random shape, they can be final, and because a record is final, it's legal to write it in that way. If it's a regular class, then you must declare it as a final class. It can also be itself sealed, which is nice, and the same rules are going to be enforced for this extended rectangle class. And if you want to have an extension point in your sealed hierarchy, then you can also declare a class, for in that case abstract, but it doesn't have to be abstract, as non-sealed. So you cannot also you can also create extension points somewhere in your hierarchy if you want to do that. There is one constraint, which is the one I just mentioned, that is all these must live in the same package or in the same module if you're in the same module. And along with seal types, you have two golden rules. The first one is that seal types are enforced both at compile time and runtime. Okay, so if you try to sneak in an implementation of the shape interface with some kind of agent or bytecode manipulation, ASM, or this kind of thing, actually the JVM will catch you. Okay, so you can try, it doesn't work. It will break your application. So that's very important, and we are going to see why in a minute. Okay, and the second point is that you cannot create extension point by accident. You have to do that explicitly. Okay, if you cannot put a regular class without specific declaration in the hierarchy of a seal type. If you want this class to be extensible, then you need to declare it explicitly. So there's no accidental extension point in a seal hierarchy. And now we are going to play with both record and seal types and assemble all this in pattern matching. Okay? So pattern matching, I think that's my personal point of view. I think that once we have pattern matching completely in the JDK, it will be a revolution in a language that is probably in the same order of magnitude as the introduction of lambda expressions. Maybe some of you remember the time before lambda expressions? Not that many, but still some of you, right? It was good to write instances of anonymous classes to create a comparator, no? No, you don't regret that time? No, nobody regret that time. That's funny, huh? Well, I do regret that time because it was hard to teach. So that was a real challenge, and I like challenges. No, I'm kidding, of course. Okay, so lambda expression really changed everything in the language. And once we will have pattern matching, it will be the same kind of change. Now, the big difference between the introduction of lambdas and pattern matching is that lambdas arrived all at once in Java 8. In one go, big bang, lambda expression were there. Okay? Pattern matching, we had a first piece of them in 16, then a second one in 17, then another one in 18, and it will go along bit by bit, piece by piece, we will have pattern matching slowly. So it's not going to be a big bang, but in the end, it'll still be a revolution. So maybe some of you have already written this kind of code. Yes, you check if this object is an instance of user, and if it is, then you're good to cast it because the compiler cannot do anything for you. Yes, I know that this O is in fact a user, but you need to tell me again because I like to, be told things twice. That's the old way of writing it. Now with pattern matching, for instance, we can write this kind of code in that way. Maybe some of you already use this kind of code in your application? Yeah? Not that many. Okay, so actually you can write it in that way. Okay? So you see that you declare actually a variable of type user, which is called user, along with the instance of operation. Now you may be thinking that this is just a syntactic sugar, something that is nice to have, and it exists in many other languages. It's actually the first, how could I say, the first bit of pattern matching that has been added to the language. This user is actually a pattern itself, and this pattern has a name. It's a type pattern because what you are matching is really the type of O, checking for the type of O. The user is the name of the pattern. Okay, you are matching with the class, and the user lowercase, maybe I should have called it in a different way to make a difference, is called the binding variable or the pattern variable. And as we are going to see it, you can have more than one binding variable or pattern variable in a pattern. Okay, in this pattern there's only one, but you can have more than one. And O is the target operand. This is what you're matching, actually. So you can use this binding variable wherever it makes sense to use it. Okay, so if you want to check if the user is older than 20, for instance, you can write it in that way with this AND Boolean operator. That's a regular AND Boolean operator. All right, and because it makes sense, because after this AND, the user variable will exist, you can use it. If you add an OR Boolean operator, then this user variable may not exist, so it wouldn't be possible to use it in that case. Now, remember that my user was in fact a record, could be in fact a record with a name and an age, and there is a second type of pattern, which is still a preview feature, pattern matching for instance of, and type pattern are not preview features anymore, they are final features in the JDK. Okay, and now you can write this kind of code. Because user string name int age is itself a pattern, you can use that pattern in the instance of. And now it will deconstruct this record, this O object, which is in fact a record, and create two pattern variables, name of type string and age of type int. Now this works well. Why does it work well? Because you know that this record has actually two components, name and age, and it's bound to have them. Okay? It has the right constructor, and what you are really doing is you are deconstructing this record to extract the components of this record. Now, could it work for a regular class that would have a constructor defined in that way? The answer is no, not yet, but in the future it will work for regular classes also. Okay, that's the plan for the future. It's not done yet. By the way, if you also need the reference to the user record, you can also add a user declaration in that way. Maybe you will not need it, but in case you need it, you can have it. To be honest, I don't know why you would need it, because the only thing you can do with user probably is just to call its accessors, and you already have the result. By the way, when you get the variable name and age, what you will also get, the value that is put in name and age is obtained from the record by using the accessors. So if you have some defensive copy in the accessor, the defensive copy will be called to give a value to name and age. Yes, question?
When you do this sort of deconstruction, let's say if I tried to assign to age, would it allow me to do that?
No, because age is a final variable. It would maybe. Okay, I'm going to be more precise. Maybe you can. I don't think you can, but maybe you can. But if you do that, it will certainly not modify the value within a record. Yeah, absolutely. A record is immutable. There's no way you can mutate its internal state. So that's two patterns: a type pattern and a record pattern. First one is a final feature. Second one is a preview feature. But you can already play with it. And the plan is that it still be a preview feature in JDK 21 to be released next September. Now, how can we mix all this with CIL types? Well, we can mix all this with CIL types in a switch expression. You know that, who likes switches? Oh, 4 people. That's okay. That's more than unexpected. You know that recently you still have the good old switch statement that no one wants to use and that basically no one's used. That's what the statistic shows. But it became a switch expression. I can't remember the exact version, by the way. Was it 16? I think it was 16. Not sure, but it's in 17. Okay, and now you can write a switch expression like that. Now, previously you could only switch on ints, not long, not Boolean, chars, shorts, and enumerated values, and starting with Java 7, strings of characters. Now you can also switch on patterns, which is new, okay? And this is an example here. I have this CIL type there with 2, suppose they are records, square and circle, okay? The first case is square, square, that's a pattern, that's a type pattern. And the second case is circle, circle, that's also a type pattern. So I'm switching on that. Basically what I'm saying is that if this shape is of type square, then create this square variable for me, and in the rest of this branch, I'm going to do something with square. And this is what I'm doing here. And the same for circle. And as you can see, I do not have a default clause in this switch expression. It's not needed. And if it was there, the compiler will give me a warning, hey, you don't need it. Okay? Why isn't it needed? Because precisely this shape type is sealed. So the compiler knows that there is no way there could be another type implementing the shape interface. Okay? Neither at compile time, nor at runtime. And by the way, because we have 2 patterns, this is a type pattern. We have 2 patterns, type patterns and record patterns. It's also legal to use a record pattern here. And you see that on the right, basically, why do I need square? It's just to call edge and to get the edge of the square. And the same for circle. I only need the radius. So what about writing this code in that way? Telling that, oh, by the way, this square is just a record built on a component called edge. And same for circle, which has just a radius. So now I can deconstruct them using the record pattern, okay, and just use edge and square in the right hand. Yeah, question?
So if you just, in the switch statement, if you just had square and not circle, would it like throw an error or blow up and say like, hey, I noticed
Yeah,
2 that you need?
absolutely. So the question is, if I forget a branch, okay, then this code will not compile. The compiler will tell me, hey, you are missing 1 case here. And by the way, if you are adding a type, suppose you have a bunch of switch like that in your application all over the place, okay? And if you are adding a permitted type within this sealed hierarchy, all your switch expressions are going to throw compiler errors. So that you will not have to check for yourself. The compiler will tell you, hey, you need to add a branch here, 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 and there, which is a safety for you. It's a safe situation. All right. So what's in it for patterns in the future? The next thing we should have in 21, it's on track. It's called the unnamed pattern. Suppose you have a record point and a record circle, and the circle as a center. So center is a point, and a radius, which is a double. Okay. Well, you can check for the instance of O by nesting the 2D constructor one into the other. And here you have 3 binding variable or pattern variable, x, y, and radius, the coordinates of the center of the circle and the radius of the circle. So you can compute the surface. But if you take a closer look at that, for the surface, you actually don't need the center of this circle. So the runtime is doing too much of a job. It's calling 2 accessors to give a value to x and y, you are not using them. So the unnamed pattern is about telling, hey, I'm not going to use the center. So you just replace this pattern by this underscore, and this underscore is itself a pattern, actually, in the base theory of patterns, telling that, hey, you don't need to to extract, to deconstruct this component because I'm not going to use it. Okay? Maybe some of you remember that it was forbidden, starting with Java, whatever version, to use underscore as fields in your classes. Maybe some of you remember that? Nobody? Great. That's a good. Yes, you did. So okay, so that's the unnamed pattern, and that's the next thing to come. Now, as a preview feature in JDK 20, there is another place where you can use pattern, which is the for loop. So suppose you have a record, which is a point here, and you have a list of points, list of record, which is of course perfectly legal, and you are just looping over the elements of this list by calling this code. And then you see that the only thing I'm doing here is just I'm just calling the access. I don't need this P reference. In fact, all I need is X and Y. Okay? But point P column points could be seen as a pattern itself. And this is what has been proposed in the JDK 20, to be able to write this code in that way. Okay? That is to put a pattern on the right part of the for each statement and deconstruct directly each element of the list. And this is actually working in the JDK 20. Now, this is working in the JDK 20. It's going to be removed temporarily in the JDK 21. So it's not in the JEP that is carrying on with the record pattern, because it's actually an assignment, and we will have probably a specific type of operator to assign a variable to a pattern and to be able to deconstruct this variable automatically. Okay, so this is going to be put on pause, left aside, and will be removed from the JDK 21. That's the plan as of now. Okay, so this is what I wanted to tell you about pattern matching. You saw type patterns and record patterns. Record pattern is still preview, by the way. This should be in orange and not in green. Nested pattern is the fact that you can put a pattern within another pattern. That's circle, point x, y, radius. And the unnamed pattern that should come as a preview feature in the JDK 21. There's another type of pattern that that is still in a work, which is called array pattern matching, to automatically deconstruct the elements of an array. The idea is say, okay, is this an array of string with a name, a first name, last name, etc., and maybe the rest, and deconstruct this array automatically. So these are the different elements that we can see in the future or in the close future. And there's another one, the deconstruction using instance method and factory method. Now the problem is that there's no syntax for that yet. People are working on it. But the idea would be to say, okay, is this object is a map entry of key and value, and automatically deconstruct the key and value to extract them? Or is this object is an instance of an entry, and the entry has to be, I don't know, address, and then give me the value that you have in front of it. That's the plan of this deconstruction. And ultimately, if one day in Java we have literals to build lists and maps, as people have been having in C#, for instance, for years, then you could also imagine having patterns to deconstruct using literals, using similar syntax as literals. So that's for the future of pattern matching. As you can see, this is just the beginning. There's more to come than what we already saw. And as for the elements on which you can use patterns, so far you can use patterns on instance of and switch. That is either final feature or a preview feature of in the JDK. And this for each statement, that will come again. That for the moment is on pause, but that will come again in the future. And the last one is the assignment operator, finding an assignment operator, maybe let, maybe match. There are discussions about that. And be able to automatically check if a variable, deconstruct a variable in a pattern directly to deconstruct this stuff, or to call a named pattern that has been defined on the class if it's a regular class. Okay? So that's for pattern matching. Is it great? Do you like it? Yeah, we do like it. We love it. Okay, so that's what's for pattern matching. Pattern matching leads to something called data-oriented programming, and I'm sorry I'm not going to talk about it, but if you want to discuss about it, I'll gladly have a discussion with you after the talk. So the second element is the Loom part. Now, Loom is a new concurrent programming model. It has been around for about a year as preview feature and incubator feature. The first thing it brings, and the first thing it will bring to the JDK, and actually it's currently on track to be delivered as a final feature for the JDK 21, so that's the next release of the JDK, is this notion of virtual thread. Now, virtual thread is a thread. All that works super well with threads are working in the same way with virtual threads, like race condition, deadlocking, visibility issues, all this kind of good stuff, all right, that we love. The biggest difference between a virtual thread and a platform thread is that where a platform thread takes about a millisecond to start and eats up, it's not 20 megabytes, so it's 2 megabytes of memory. A virtual thread, on the other hand, takes about 1 microsecond to start and eats up, as of now, several hundreds of kilobytes of memory. There are optimization underway, and it should drop by a factor of 10, so to reach several tens of kilobytes of memory. So in a nutshell, where you can have on the same machine something like 2,000 to 3,000 platform threads, okay, you can have 1 million virtual threads on the same machine. 1 million platform threads would take about 20 minutes to launch and would eat up about 2 terabytes of memory. So there's no way you can have 1 million platform threads on a regular machine. But 1 million threads on a million virtual threads on a regular machine, that's just easy, even on this laptop. No problem with that. The second thing is that it is cheap to block a virtual thread. Okay, blocking a platform thread is actually expensive, and this is why you're doing asynchronous programming. It's precisely to avoid having to block a platform thread. Well, for virtual thread, a virtual thread is built on top of a platform thread, so you have the stack of your platform thread, and then the stack of your virtual thread. If a virtual thread sees that it's blocking, then it will be moved. The stack of this virtual thread will be moved to the heap memory, freeing the platform thread, so not blocking the platform thread, and then the platform thread becomes available to run another virtual thread that is not blocked. And when the signal comes for this virtual thread, hey, your JSON object is there, hey, the result of the query you launched on this database is there, then this platform thread will be brought back on the virtual thread, this virtual thread will be brought back to the platform thread and will be able to run again. So blocking a virtual thread, the price of blocking a virtual thread is the price of moving 200 kilobytes back and forth from the stack to the heap. So it's not free, nothing is ever free, but it's much cheaper than blocking a virtual thread and having to switch the context of this platform thread. Okay, so Looms works with a limited number of platform threads. It doesn't need many platform threads. On my machine, which is a 12-cores machine, 9 platform threads is enough to run 1 million threads, 1 million virtual threads. No problem with that, which means that it's become much cheaper to do this kind of thing, to block your code and to do I/O. Launching a thread is cheap. Blocking a thread is cheap. Do you need to pull threads? Quick answer, no, you don't. Okay, if you want to test that, you have a special executor service. So if your application is built on top of an executor service, then you can use this one that will not pull anything. It will just take your runnable or your callable, execute them in a virtual thread that is created on demand, and let this virtual thread die after that, because you don't need to pull virtual thread. It's useless. Now, because creating virtual thread and blocking them becomes so super cheap, there is a new approach to asynchronous programming that is coming called structured concurrency, and that's the second part of the Loom project. There is a third part also that I'm going to talk to you about. So if you take this problem, for instance, you have a travel page that you want to build, and you have 2 information on this travel page: the price of the travel you want to buy, and the weather forecast to tell you that, yes, it's great, you should go there. The sun is shining there at the moment. It's Paris, there's no strike. I really don't... I find it quite shocking that you're laughing at that joke. Hey, don't go to Paris. That's a mess. Okay, if you want to program this stuff with the CompletableFuture, that's the kind of code you will need to write. Who likes to write this kind of code? Yes, no one. Who likes to debug this kind of code? Okay, no one. Who likes to write unit tests for this kind of code? No one neither. Okay. And actually, this code is a simplification of the real code you want to write. Because the real problem you want to solve is this one. You want to query several quotation servers and take the best one, the best price. And you want to query several forecast servers because you want to have the weather forecast as soon as possible. So just like some kind of DNS server, for instance. Well, this is the kind of code that the Structured Concurrency API allows you to write. Okay, that's for the quotation scope. You create a scope object by extending a class called Structured Task Scope. And then you fork your task. If you have 50, fork. Okay, and then you wait for all the tasks to complete. And then you need to program a best quotation method to get the best quotation that you got. Okay, from all these tasks. And to get that, you need to actually write a single method in this quotation scope object, which is this one. It's a callback on the completion of each task you launched. The completion of a task returns a future, but you want to process this future internally within your scope object and just accumulate the result you got, all the exception you got, in a concurrent collection. And this is what this code is doing, basically. Super simple to write. And once you have accumulated all the results from your future object in this collection, which is here just quotations, you may write this get best quotation method in that way. Just a matter of finding the mean of a collection, which is a good job for the Stream API. Okay? So you replace a code that is hard to read, hard to write, hard to test, hard to whatever, okay, by a piece of code that is synchronous, blocking, imperative, super easy to test, easy to write, easy to maintain, and which is run on top of virtual thread, so that is super efficient. By the way, this is also the code you can write for your travel scope page. Same kind of code, same kind of pattern. There's not much different to it. Okay. Now the third element brought to you by the Loom project. Yes, question, sorry?
Is there any performance implication between the two approaches?
Sorry, can you say that again?
Is there any performance implication between the two approaches?
Which one was the first one?
The CompletableFuture and then the virtual thread.
So the question is performance differences between CompletableFuture and virtual threads. CompletableFuture is blocking platform threads, okay, unless you're really super smart and you want to avoid that. Whereas structured concurrency is blocking virtual threads. So whatever you do, you will be able to process more requests per second with virtual threads than with platform threads. And I mean, even if the performances were the same, on the one hand, you have a code that is horrible to read and maintain, and on the other hand, you have a code that is super simple. So go for it. The last thing that the Loom project is going to give you are called scope values. And that's an incubator feature of the JDK 20, and it's a new model for thread local variables. Now, thread local variables are fully supported and work with virtual threads. Okay, so if you have an application, you want to test it with virtual thread. By the way, Spring Boot is working on virtual thread already, right? So it's not hard to do. Just change your executor service and see if it works. If you are using thread local variables, then it's okay. It will work with virtual thread. If it doesn't, that's a bug and you need to report it. Okay. Who is using thread local variables? Maybe some of you? Yeah. You know you have a remove method on thread local variables? Okay. And you're using it, right? Yes. Okay. Good. Now, scope values are different. They work in a different way. First, they are immutable. You cannot modify a scope value. Whereas you can modify a thread local variable, which may lead to hard to debug code. Second, they are not bound to a particular thread. It's actually not, a thread local variable is bound to a thread. A thread is bound to an executor service, and your executor service is bound to your application. So if you're not careful and you never call remove, then your thread local variable will exist as long as your application is alive, which is not a good thing. For scope values, your scope value is not bound to a particular thread, it's bound to the call of a runnable. This is the pattern to create a scope values and to bind it to a specific runnable. So you create one with scope value new instance, okay? And this key object should be accessible to wherever you want to read it. So it's probably a public static file or something, right? And when to bind it, you call where bind key to here key one, run the do something smart runnable, and every code that is called under do something smart will have access to the key one value bound to this key scope values. Okay? And I didn't launch any thread here. Everything is happening in the same thread. And when you return from the method, it's done. The binding is broken. All right? So if this runnable is actually spawning scopes, structured task scope, spawning thread, platform, virtual, whatever, this key one value will be available in all these contexts. All right? Wherever you launch a new thread or not. You can have several runnables, several keys, etc. The API itself is quite versatile. Scope values are non-modifiable. They are not bound to a particular thread. Okay, and to read it, that's the code. You have an isBound method, a get method. If isBound returns false and you call get, you will have an exception, so don't do that. All right, and you can do that from wherever you want. Any thread, any scope, any whatever. So 3 things for Loom: virtual threads, structured concurrency, scope values. Virtual thread is on track to be a final feature of 21. Structured concurrency should still be an incubator API, and same for scope values. All right, and for the last part, Valhalla. Now, if you think that Loom is doing some magic, you're in for a big surprise with Valhalla, because Valhalla is really doing amazing stuff. Of course, everybody knows this book. I'm not going to ask who doesn't know this book, but if you don't know it, then you should consider doing something about it, right? Page 20 of this book is the introduction, and it's written because I'm showing this page because some people came to me previously telling me, no, it's not written in the book. Okay, so favor object composition over class inheritance. This has been written in 1993 or 1994, all right? 30 years ago, people said, stop doing inheritance. Do object composition instead. Records are about favoring composition over inheritance. Why don't you follow this principle? Because nobody does that. Okay? Yes, do you do it? No, you don't. Nobody follows that. Because modeling is actually expensive performance-wise. You prefer to sum an array of ints rather than writing the sum of a series of population objects. But if you write population objects, your code will be more readable because you know that this int represents in fact a population. But you don't do that because you care about performances. And if you do that, you will have indirections all over the place and will just crush your performances. Even if it crashes them in the order of the nanosecond and you're in an HTTP thread, that will take milliseconds to launch a query or whatever, but that's another discussion. So the first goal for Valhalla is to make it so you do not have to choose between good model and good performances. Create a good model and you will have the good performances. That's the goal of Valhalla. Okay? Make abstraction almost free. And Brian Gertz used to say, maybe some of you remember that, codes like a class, works like an int. Okay, so suppose you have an array of populations, which are actually ints, and you can sum them, and you can sum them either in a loop or in a stream, probably a stream is more readable. What you want to do is actually sum real population records in that way, either in a loop with the add method, because you added an add method on this record, or directly in a stream. Writing things in that way brings more readability to your code, because now you're not manipulating ints that are supposed to be population, and you put that in a comment. You are really manipulating population objects. But it's the same for creating histograms, for instance. Okay? That's an histogram of population by cities. Bad luck, it's string and integers. What you really would like to have is this kind of thing. A city, a population object, and have a map of city of population. And you don't do that because, of course, the performances will not be the same. Okay? So Valhalla brings the first notion of value classes. A value class is a class, regular class, declared by value, and I'm going to show you the syntax that people are working on currently, which is implicitly final, meaning all the fields are final. It does not have an address. No address for a value class. Why? Because you want to be able to inline it wherever you use it. So if you give it an address, it will not work. If it doesn't have an address, it means that you cannot synchronize on it. So you give up on synchronization. It means that if you call equal equal on it, which compares references, that is addresses, in a JDK, well, if there's no address, then you cannot compare addresses. So it has to compare actually the value of the fields carried by this class. Okay? And its constructor does not call a constructor from a superclass. So that's a kind of object that is a little special in the zoology of objects currently. So that's, for instance, a value class, just declare with value, and all the rest is a regular class, just not compiled in the same. There's bytecode, specific bytecode stuff in it, okay, so that the JVM can optimize that in the right way. And because they do not need to be stored as an object with an address, value object can offer better performances. No pointer chasing, because you can inline them. They can be stored in contiguous zones of the memory, so if you are just streaming them, it will be faster. And they can be inlined in variables and registers. That's the goal. And it's already working on the early access versions. You can actually test that and make performance benches with JMH on this kind of thing. Okay? So that's for the value classes. The second type brought by Valhalla is used to be called user-defined primitive classes, but it's going to be changed, and the name is not final yet, so I'm still going to use them, user-defined primitive types. What is a primitive type? Like int, double, long, this kind of thing. It's not an object, doesn't have an address. When you call equal equal on it, you compare the values. If you call I equal equal j, where I and j are integers, you are really comparing the values, so just like value types. And it does not make sense to modify them because 2 is a value, and you cannot mutate 2. It doesn't make sense to say that you're mutating an integer. Right? But there is some more. It cannot be null. When you declare an array of int, you cannot put a null value in it. Man, that's embarrassing because an object can be null. A reference to an object can be null. Okay. So how can Valhalla extend this notion of primitive types to value objects? The real question turns out to be how to deal with null value. A primitive type cannot be null. So if you want an object to be seen as a primitive type, it means that it cannot be null neither. And that's a problem because if you have, for instance, a record that is a point, and you want to create an array of points, and you say, okay, this point is actually not a real record, it's a primitive record, so I want to avoid it to be null. So you say, okay, instead when I create an array of points, it means that I do not have any null value in this array. Maybe I can define some kind of default value for this point with default values for x and y. So it's actually an array of points that are all equal to 0, 0. All right, but the problem is that this array, you can put it in a list, and then you're doomed. Because on the list, it's legal to call this kind of code. That's not working. You need to find something smarter. to tell the compiler, hey, this list cannot have null values. So you need a new syntax for that. First, you need a syntax to say, hey, this record is actually a primitive record. And when you create such a record, what you have is not a null value, it's a record with default values for its field. Okay? So you need something to define default values. And after that, you need to modify the type system so that you can say, hey, the reference to this record cannot be null. And you don't have anything like that in Java so far. So Valhalla is doing this kind of thing, value record, and I'm going to add this kind of default constructor, and that tells me, okay, this record can have a default value, which is by default, all the fields have default values. Okay? You can still have all the semantics of the record that I talked to you about just a few minutes ago. You also have the problem of tierability. I'm not going to go into the detail. This has to do with concurrent programming. But then, when you use this kind of record, you have two ways of defining an array of primitive records. The first one is the regular one, and this array can actually have null values. But the second one with this exclamation mark tell, hey, this array cannot have null values. And when you declare that, then it will be filled with default values instead of null values. Okay? And now, when you, and it's the same for the component, by the way. You can also say, hey, this record has a center, and this center cannot be null. And now, when you define a list built on such an array, okay, you can also say this list cannot have null values with this syntax, which is a new syntax. It's still on the work, right? It may change, but this is what people are talking about at the moment, and this is what they're working on. Okay, so that at the compile time, when you call point.set0 null, the compiler will tell you, hey, you are trying to put a null value in something that does not accept null value. So you will have a compiler error at this point. Okay, and if you do all this, summing your array or your list of population will have the exact same performance as summing an array of ints. Because in memory, what you have is an array of ints. You can have this kind of syntax, okay, which is kind of weird, but it works. You can call, yes, double value, this will work, okay. And you see that this list of integer bang, this is how people are reading it, list of integer bang, has actually the same memory representation as an array of ints. So all the performances, if you want to sum these ints, find a min, find a max, whatever, all the performances are the same, which is great. All right, so to wrap it up, because we're almost out of time, these primitive types look like the user primitive type are handled as primitive types. You can see just that as a pair sequence of values laid out nicely in memory with no object header, so you're saving on memory, you're saving for performances, you're saving for everything. It allows you to decide where you use. At the point where you use these kind of objects, you can decide whether you want to handle null values or not. And if you don't want to handle null values, you give up on handling null values, you will get new performances and better performances. Okay, and I'm going to skip that bit because we are really out of time. And that's it. There are several things you need to be aware of. This constructor has been deprecated for removal, and when Valhalla makes it as a final feature, it will be removed from the API. Okay, so stop calling that. The drop-in replacement is the value of method. And as for the primitive type, there are many places where primitive types will be used, like optional local date, duration, time, local time, all this good stuff. Okay? And I think we are out of time, so sorry for that. All this is great. Thank you.